At 10 minutes to 2 in the morning, the monitoring team stationed at Chernobyl heard an explosion above their heads. Flames appeared near the top of a vast white arch. Something had punched through the roof of the structure, built to keep the worst nuclear accident in history, sealed away from the world. That was the 14th of February, 2025. The hole itself was modest, roughly 15 square meters of torn cladding. The fire was the real injury. It crept sideways between the steel skins of the arch and smoldered for weeks in a place no firefighter could reach with a hose. This was not an ordinary industrial roof. Beneath it sit the crushed remains of Reactor Number 4 and an estimated 200 tons of melted nuclear fuel that no one has ever removed. Which brings us to a question engineers spent 20 years answering. How do you build a structure larger than most stadiums over a reactor that is far too radioactive to stand beside? To understand what was damaged that night, you have to go back to April 1986. Reactor Number 4 ran out of control during a test. The explosion tore the building open, scattered graphite and fuel across the site, and left the core burning in the open air. Helicopters dumped sand, lead, and boron into the wound. The fire eventually died. The radiation did not. By late May, Soviet engineers faced a simpler and uglier problem. The ruin was open to the sky, and every rainstorm and gust of wind could carry contamination outward. They needed a lid, and they needed it before winter. What they built is usually called the sarcophagus. It went up in 206 days. It consumed more than 400,000 cubic meters of concrete and around 7,300 tons of steel framework. But the radiation dictated the construction method, and that is where the trouble began. Workers could not linger to bolt joints tight or run welds along seams. Cranes lowered enormous steel elements into place, and operators guided them from a distance. Many pieces simply came to rest against each other. The result was a shelter with roughly 1,000 square meters of gaps, where components never quite lined up. It leaked light, it leaked rain, and it was never designed to be permanent. The second problem was worse. The sarcophagus did not stand on its own foundations. Parts of it leaned on the wreckage of the reactor building underneath, including a wall the explosion had already damaged. So the world's most dangerous ruin was being held up, in part, by another ruin. Water seeped in through the gaps and pooled in the basements. Steel corroded in the dark. Dust settled on every surface, and sprinklers had to spray a chemical solution inside just to keep that dust from lifting into the air. By the mid-1990s, engineers concluded the structure could not be repaired to any meaningful standard. Braces and reinforcements bought perhaps another 15 years. Everyone understood the deadline. If the old shelter collapsed, it would slam a mass of concrete down onto contaminated debris and throw a cloud of radioactive dust across the site. The obvious answer was to take it apart. That was the one thing nobody could do. In places inside, radiation was measured in thousands of roentgens an hour, and a human being can absorb a lethal dose in minutes at those levels. You cannot send scaffolders into a room like that. The second obvious answer was to build something stronger directly over it. That failed for the same reason. A construction crew standing next to Reactor Number 4 burns through a career's worth of permissible exposure in a matter of weeks. So the design that finally won carried a strange instruction. Do not build over the reactor. Build somewhere else entirely, 300 meters west, where the ground had been scraped clean. Build the whole thing there. Then move it. The structure is called the new Safe Confinement, and its dimensions only make sense once you know why it exists. It rises 108 meters, about the height of a 35-story tower. Its clear span is 257 meters, wide enough to arch over 2 football pitches laid side by side. It is 162 meters long. Equipped, it weighs 36,000 tons, roughly 5 times the iron in the Eiffel Tower. Every one of those numbers is driven by a constraint. The arch had to swallow the old shelter whole without touching it. It had to leave working room underneath for demolition machinery. And it had to reach down to clean ground on both sides because there was nowhere inside to plant a column. The arch shape did several jobs at once. It carries its load and compression down 2 curved lines to the ground. It needs no internal supports over the contaminated zone. It sheds snow and wind. And critically, a smooth curved profile is far easier to slide than a box. Look closely and the arch is not solid at all. It is a lattice of tubular steel members, triangulated like a bridge truss, wrapped in an inner and outer skin of cladding. That lattice carries the weight of the arch, the weight of the cranes hanging inside it, and eventually the weight of whatever those cranes tear down. The foundations were their own radiological problem. Two long concrete beams run the length of the site, and they had to be founded on deep panels sunk into soil that was itself contaminated. Engineers stripped the hottest surface layer with rope-operated grabs, then excavated the deeper material under a protective slurry, keeping the dust wet and buried rather than airborne. The steel arrived from Italy, prefabricated in segments. Getting it to Ukraine took 18 ships and roughly 2,500 truck movements. Then came the part that looks impossible in the footage. Rather than climbing upward, the arch was built downward. Crews assembled the top section near the ground, jacked it into the air, and slid the next tier underneath. The first lift raised more than 5,000 tons to a height of 53 meters. The second lift took the growing structure past 9,000 tons. Workers were always at the bottom, always near the ground, and always as far from Reactor Number 4 as the site allowed. That was the entire point. The east half was completed and shunted aside. The west half was built in the same space. In 2015, the two halves were brought together and bolted into a single arch. But finishing the arch was only half the problem. It was standing in the wrong place. 36,000 tons had to travel 327 meters and come to rest over a decaying ruin, with enough precision that the end walls would seal. There were no wheels. The arch sat on Teflon pads riding on the concrete beams, and it was pushed by a skidding system of 224 hydraulic jacks. Each stroke advanced the structure 60 centimeters. Then the jacks reset, gripped, and pushed again. Lasers watched the alignment. Total pushing time was around 40 hours, spread across 2 weeks so engineers could inspect after every stage. It moved slower than a person strolling, and it was, in that moment, the largest object ever moved on land. On the 29th of November, 2016, it stopped. Reactor Number 4 was inside. Sealing it was a separate campaign. End walls closed the gaps between the curved arch and the irregular wreckage of the old plant. Then the ventilation system took over, and its logic is elegant. Warm, dry air is pumped into the space between the two steel skins and held at a slight overpressure, while the volume around the reactor is kept at a slight underpressure. Air therefore leaks inward, never outward. Radioactive dust cannot migrate into the shell, and with humidity held below 40%, the steel cannot corrode, which matters enormously because nobody will ever be able to repaint the inside of that arch. Hanging beneath the lattice are bridge cranes with a span of 84 meters, operated remotely, carrying manipulators, crushers, and vacuums. Their job was never to hold Chernobyl still. Their job is to take the 1986 shelter apart, piece by piece, from a control room, with the dust trapped inside a sealed building. The new Safe Confinement was commissioned and handed over to Ukraine in July 2019. And then almost none of that dismantling happened. There was a war, which returns us to the 14th of February 2025. Ukrainian officials said a Russian attack drone carrying a high-explosive warhead struck the roof. Inspectors on site confirmed a drone strike and reported no rise in radiation. Moscow denied responsibility. The verified damage is narrow but serious. Both the inner and outer cladding were breached across about 15 square meters, with around 200 square meters of panels affected, along with joints, bolts, and systems needed to run the cranes and the ventilation. The waterproofing burned. In December 2025, the International Atomic Energy Agency stated plainly that the structure had lost its primary safety functions, including confinement. It also stated that the load-bearing structures and monitoring systems suffered no permanent damage. The arch still stands. It is simply no longer sealed, and an unsealed arch is a corroding arch. Crews closed the hole temporarily before winter to keep precipitation out. A technical assessment by the original builders put full restoration at around 500 million euros. Funding commitments of roughly $500 million have been mobilized, with early engineering underway, heavier work expected from 2028, and completion targeted for 2030. That deadline is not political, it is chemical. The protective coatings on that steel expire. And this is the lesson buried under 36,000 tons of lattice. The new safe confinement never erased Chernobyl. It could not. It bought 100 years of dry, sealed, remotely operable working time in which the ruin could finally be taken apart. That is what a drone punctured on a February night. Not a roof, a clock.